Hello everyone, in this video we're gonna learn how to solve this challenging trigonometric intro from the 2024 India Cheese Events. Alright, so the key information in this problem is we're gonna use King's rule. Alright, so most of the advanced trigonometric integrals we're gonna use King's rule to solve it. Integral from a to b of f of s ds is equals integral from a to b of f of a plus b minus s ds. Alright, so we're gonna let t equals pi over 2 minus s. So we have dt equals negative ds, right? Now s equals 0, t equals pi over 2, s equals pi over 2, t equals 0, right? Now I'm going to call this one I. So I have I equals integral from pi over 2 to 0 sine square of pi over 2 minus t, right? Over 1 plus sine pi over 2 minus t cosine pi over 2 minus t, right? dt, and I put the negative side in the front, right? Now, this guy turns out to be integral from 0 to pi over 2, right? Because I have the negative side over here, so I just switch the powers, right? And then this guy becomes positive, right? Now sine square of pi over 2 minus t turns out to be cosine square of t over 1 plus cosine t, right? Times sine t dt, right? Now the variables right here agrees, right? So I just switch this one to s, right? So this one is the same thing as, and this guy actually I, right? Now I just solve that I equals this one, right? So I'm gonna add this one up vertically. So I have 2i equals the integral from 0 to pi over 2, right? This guy and this guy have the same denominator, right? So I just rewrite denominator. Now the top side square of s plus cosine square of s is going to be 1, right? Now we know that sine 2s equals 2 sine s cosine s, right? So I'm going to divide both sides by 2. And then this one cancel out, right? Now I'm going to substitute sine 2s over 2 for sine s cosine s in this integral, right? So I have, now I'm going to multiply the top and bottom by 2. So I'm going to have 2i equals, now I just change the variable. What if I let t equals tangent s? Right? I use double formula right here. And then I have sine 2s equals 2t over 1 plus t squared, right? Remember that this angle right here double this one, right? And then we can apply the formula right here. This guy right here must be double this guy, right? So then I just replace t with tangent s. So this guy turns out to be 2 tangent s over 1 plus tangent square of s, right? So this one turns out to be 2i equals integral from 0 to pi over 2. Alright, 2 over 2 plus 2 tangent s over 1 plus tangent s square, right? ds. Now first I need to divide both sides by 2. So this one cancel out. this one becomes 1, right? Next, I'm going to multiply the top bottom by 1 plus tangent square of s, right? So this one 1 plus tangent square of s. This guy 1 plus tangent square of s. Right? So this one and this one cancel out. Right? Now I have I equals integral from 0 to pi over 2. Distribute this guy over here. So I have 1 plus tangent square of s over 2 times 1 plus tangent square of s, right? Plus 2 tangent s ds, right? Now this guy turns out to be the bottom right here. I factor 2 out, so I multiply both sides by 2. I have 2i equals integral from 0 to pi over 2. 1 plus tangent square of s, I just use the formula. It's going to be secant square of s ds, right? The bottom right here turns out to be tangent square of s plus tangent s plus 1, right? Now let's use substitutions. So I'm going to let use equals tangent s, then du equals secant square of s ds, right? Now I'm going to change the bounds, right? The upper bound is going to be s equals pi over 2, then use equals tangent of pi over 2 is undefined, right? So it can be infinity, right? Now s equals 0, then use equals tangent of 0 equals 0, right? So I substitute back over here, so I have 2i equals integral from 0 to infinity du over u square plus u plus 1, right? Now I'm going to use the complete square formula to solve this problem, right? Before I'm going to do that, I need to rewrite 2i equals, because this one is improper integral, right? So I need to convert it to limit. So I have 2i equals limit of the integral from 0 to b du over u square plus u plus 1 when b approaches infinity, right? Now, to do this one, I need to use complete square formula, right? So this guy turns out to be limit when b approaches infinity, integral from 0 to b du over u plus 1/2 square plus root 3 over 2 altogether square, right? Basically, you just take the middle term right here, you divide by 2, 1 divided by 2 and square, and you add and subtract 1/4, right? Now we have the formula, the antiderivative of du over u square plus a square equals 1 over a tangent inverse of u over a plus c, right? Now in this situation, use which means the whole thing right here, right? This one is a, right? Then we have 2i equals limit when b approaches infinity. Now take antiderivative of this one, it turns out to be 1 over root 3 over 2, right? Tangent inverse of u plus 1/2 over root 3 over 2, right? Then evaluate this one from 0 to b, right? Now we substitute this guy into this expression, so we have limit When b approaches infinity, this guy turns out to be 2 over root 3, right? Now tangent inverse r, b substitute over here, it's gonna be b plus 1 half. Root 3 over 2 turns out to be 2 over root 3, right? So I multiply this one by 2 over root 3. Subtract tangent inverse of 1 half over root 3 over 2, right? Now this guy becomes 2i equals 2 over root 3. Now limit of the first one right here. When b approaches infinity, tangent inverse of this one approaches tangent inverse of infinity, which is pi over 2, right? So I have pi over 2 for this guy. Now second one, tangent inverse of this one is going to be, I multiply the top bottom by 2, so I have tangent inverse of 1 over root 3, right? And it's going to be pi over 6, right? So I subtract pi over 6, right? Now I'm going to divide both sides by 2. So I equals 1 over root 3 times pi over 2 minus pi over 6. Now this guy becomes 1 over root 3 times 2 pi over 6, right? 2 and 6 cancel out, so I have 3 on the bottom, right? So the answer should be pi over 3 root 3, right? And this is the final answer. We're going to learn how to solve this integral from the Indian cheese advanced past paper. Alright, we need to calculate the integral from -1 to 2. Absolute value of s minus absolute value of s minus 1 ds, right? Now, in order to solve this type of problems, we need to find a breakpoint, right? So we have absolute value of s equals s if s greater than or equals 0, negative s if s less than 0, right? Now you have absolute value of s minus 1. Similarly, you have absolute value of s minus 1 equals s minus 1 if s greater than or equal to 1, right? And 1 minus s if s less than 1, right? Now, the breakpoints right here, 0 and 1 right here, right? So we're going to put this guy on the table right here. So I have the starting point is going to be -1. The end point is going to be 2, right? So -1, 2. The breakpoint is going to be 0 and 1, right? So I put 0 here and 1 here. Now, the first expression is this guy right here, right? So I put absolute value of s. Now the second one is going to be this guy, right? Absolute value of s minus 1, right? Now for this guy right here, I'm going to put this guy right here, right? Now go ahead, draw the line right here. Alright, now we have 3 intervals, -1 to 0, 0 to 1, and 1 to 2, right? Now from -1 to 0, we know that if s less than 0, and then it's going to be negative s, right? So this one should be negative s, right? Less than 0. If s greater than or equal to 0, it's going to be s only, right? So this guy s, this guy should be s because it's greater than or equal to 0, right? Now, for this guy right here, s less than 1, it's going to be 1 minus s, right? So 1 right here, so it's going to be 1 minus s, 1 minus s, if s less than 1, right? Now, if s greater than or equal to 1, it should be s minus 1, so this guy should be s minus 1, because s greater than or equal to 1, right? Now we need to subtract this one vertically, right? So negative s subtract 1 minus s, it should be negative 1, right? This guy subtract this guy, it should be 2s minus 1. This guy subtract this guy should be 1, right? Now this integral becomes integral from negative 1 to 0, right? The answer is only negative 1, right? So we put negative 1 right here, ds. Next one, add the integral from 0 to 1, right? The answer should be 2s minus 1, ds. And the third one, the integral from 1 to 2, right? The answer should be 1 right here, right? ds. So it's going to be the first one right here equals negative s evaluated from negative 1 to 0 plus s squared minus s evaluated from 0 to 1. And the last one plus s evaluated from 1 to 2, right? So this guy becomes 0. Substitute over here is going to be 0, right? Now the second one should be subtract negative of negative 1, right? This guy right here turns out to be 1 minus 1, right? This guy turns out to be 2 minus 1, right? Now simplify this one, it's going to be negative 1 plus 0 plus 1. So the answer must be 0. We're going to learn how to integrate natural log of tangent s over sine s cos ds. Alright, so observe that we have natural log of tangent s right here. We're trying to eliminate natural log. So we know that natural log of e to the s equals s, right? So we're gonna let tangent s equal e to the u, right? And then we're gonna take derivative both sides, right? So we have secant square of s ds equals e to the u du, right? And then we need to solve for ds, right? So ds equals e to the u du over secant square of s, right? But 1 over secant square of s equals cosine square of s, right? So it's going to be cosine square of s e to the u du, right? Now we substitute over here, so we have natural log of e to the u, right? And then ds can be written as this one, right? So it turns out to be cosine square of s e to the u du, right? Over sine s cosine s. Now we're going to simplify, right? So cosine square divided by cosine square, you have cosine s left right here. Cosine s divided by sine s is going to be cotangent s, right? So I have cotangent s right here. Now e to the u, I rewrite it du, right? Now this guy turns out to be u, right? Now observe that you have tangent s equals e to the u, right? Now you know that tangent s and cotangent s, they are reciprocal, right? So cotangent s equals 1 over tangent s, right? So it's going to be 1 over e to the u. Then you substitute this guy for cotangent s into this guy. So you have integral of u times 1 over e to the u times e to the u du, right? Now we're going to simplify this guy and this guy. So finally we have integral of u du, right? So this guy turns out to be u squared over 2 plus c, right? Now from this one we can take natural log both sides, right? So natural log of tangent s equals natural log of e to the u, right? So this guy turns out to be u, right? So now you're going to substitute natural log of tangent s for u into this expression right here. So it turns out to be natural log square of tangent s over 2 plus c. We're going to learn how to solve this challenging integral. Alright, we need to calculate the antiderivative of s plus 1 over s squared plus s plus 1 altogether squared. Alright, so observe that the top we have s plus 1, the bottom we have s plus 1 right here. Then we need to rewrite the top as integral of s squared plus s plus 1, then minus s squared. Alright, so basically you just add and subtract the same s squared. Alright, over s squared plus s plus 1 altogether square ds. Alright, now I can split this fraction into two fractions. Alright, so it turns out to be, I wrote this guy and this guy right here. So it turns out to be 1 over s squared plus s plus 1, right? ds minus the integral of s squared over s squared plus s plus 1 altogether square ds, right? Alright, now this one right here, we need to turn the denominator into a complete square. Alright, so basically I have s squared plus s plus 1 is the same thing as s squared plus s. Now I'm going to add 1 over 4 and minus 1 over 4 and then plus 1, right? So the first three terms right here becomes a complete square. So it's going to be s plus 1 half altogether square, right? This guy becomes 3, 4, right? Alright, so this one can be written as the integral of 1 over s plus 1 over 2 altogether square plus 3, 4 ds, right? Now, the second one right here, I can factor denominator. So I have s squared right here. The denominator right here, I factor s squared out. And you see that you have square right here, so it turns out to be s power 4. Right, so s power 4 right here. And then it turns out to be 1 plus 1 over s plus 1 over s squared altogether square ds, right? This guy right here, I can rewrite it. So it's going to be 1 over s plus 1 half altogether square plus this one turns out to be root 3 over 2 altogether square, right? And then ds right here, I can write ds as d of s plus 1 half, right? So then I can apply the formula. Now this one right here, I just simplify this guy and this guy, right? So I have s squared left right here. So this guy can be written as the integral of 1 over s squared over 1 plus 1 over s plus 1 over s squared altogether square ds, right? Now the negative side right here, I can bring this inside and then I turn this one into positive, right? Now the bottom right here, I can turn this one into a complete square, so it turns out to be what? So you have 1 over s squared plus 1 over s plus 1 equals 1 over s squared plus 1 over s plus 1 over 4, right? Minus 1 over 4 add 1, right? So I just add and subtract 1 over 4. Now the first three terms right here becomes a complete square. So it could be 1 over s plus 1 half all together square. This guy turns out to be 3, 4, right? Alright, so the first one right here, I can apply the formula. The integral of du over u square plus a square equals 1 over a tangent inverse of u over a plus c, right? Now in this situation, u, which means s plus 1 half, right? And a, which means root 3 over 2, right? So it turns out to be 2 over root 3 tangent inverse of 2 over root 3 times s plus 1 and half. Alright, so we finished the first one. Now we need to calculate this one right here. So I bought this one, right? So this guy turns out to be the integral of negative 1 over s squared over this guy right here. I replace with this, right? So it could be 1 over s plus 1 half square plus 3, 4 all together square ds, right? Now this guy right here I can write as root 3 over 2 altogether squared, right? Observe that if I take the derivative of 1 over s plus 1 half, it turns out to be negative 1 over s squared ds, right? So I just replace this guy right here with this guy, right? So I call this guy as I, right? So I have I equals the integral of 1 over s plus 1 half altogether square plus root 3 over 2 altogether square, right? And the whole thing right here square, right? And d of 1 over s plus 1 half, right? Alright, so observe that this guy is the same thing as 1 over u squared plus a squared, right? So in order to calculate this one, we just use substitution. We let u equals a tangent t, right? So then, now we use the trigonometry substitution. So we let 1 over s plus 1 half equals root 3 over 2 tangent t, right? Now we take derivative both sides, right? So we have d of 1 over s plus 1 half equals root 3 over 2 secant square t, right? Now secant square, which means 1 plus tangent square t, right? So this guy turns out to be root 3 over 2 times 1 plus tangent square of t dt, right? Forget dt right here. Now we substitute this guy back into the original one right here. So we have I equals the integral of 1 over. Now if you square this one, this guy square. So it turns out to be 3 over 4 tangent square t plus 3 over 4 right? Altogether square. And then this guy turns out to be d of this one equal this one right here. So it could be root 3 over 2 times 1 plus tangent square of t dt, right? Alright, so now next, the bottom one right here, I have 3 over 4 tangent square of t plus 3 over 4 altogether square. Now I factor 3 over 4 out. So because you have a square right here, which means you factor 9 over 16 now, right? So it turns out to be tangent square of t plus 1 altogether square, right? So 9 over 16, I print it to the front, it turns out to be 16 over 9. And then you have root 3 over 2 right here, so it could be root 3 over 2, right? So this guy right here becomes integral of 1 over tangent square of t plus 1 altogether square. The top you have 1 plus tangent square of t, right? And dt right here. Now this guy and this guy cancel out, right? So you have this guy cancel out, so you have 8 root 3 over 9. The integral of dt over 1 plus tangent square of t, right? Now 1 plus tangent square of t equals 1 plus sine square of t over cosine square of t, right? So this guy turns out to be cosine square of t plus sine square of t over cosine square of t, right? And then this guy turns out to be 1 over cosine square of t, right? So this guy turns out to be 8 root 3 over 9. The integral of dt over 1 over cosine square of t, right? Alright, so you have I equals 8 root 3 over 9. Now 1 over cosine square of t, I just flip it, so it turns out to be integral of cosine square of t dt, right? Now this guy equals 8 root 3 over 9. The integral of 1 plus cosine of 2t over 2 dt, right? Now you simplify this guy and this guy. 8 divided by 2 is going to be 4, right? So you have 4 root 3 over 9. Then you take antiderivative of this one, it turns out to be t plus 1/2 sine 2t plus c, right? Now we need to substitute the original variables back into this guy, right? So previously we used the substitution by letting 1 over s plus 1 over 2 equals root 3 over 2 tangent t, right? Now we need to divide both sides by root 3 over 2, so it turns out to be tangent t equals 2 over root 3 times 1 over s plus 1/2, right? Now we need to take tangent inverse both sides, right? So tangent inverse of this guy equals tangent inverse of this guy, right? So it turns out to be t equal to tangent inverse of 2 over root 3 times 1 over s plus 1/2, right? Now we substitute this guy for t back over here. So we have I equals 4 root 3 over 9 times tangent inverse of 2 over root 3 times 1 over s plus 1/2, right? And then now plus 1/2 right here, sine of 2 parentheses. And you copy this one down. So it could be tangent inverse of 2 over root 3 of 1 over s plus 1/2. Alright, so this is the answer for I. Now we bring this guy over here. And then we have the final answer. It's going to be this guy right here and this guy right here. We're going to explore the antiderivative of 3 plus cosine s altogether to the fifth ds. In order to solve this problem, we would have to use the binomial theorem. Alright, so go ahead, revisit the binomial theorem. So if I have a plus b raised to the n, now I need to use binomial theorem to expand this polynomial. So it's going to be combination of 0 and a to the n plus combination of 1 and a to the n minus 1 b plus combination of 2 and a to the n minus 2b squared plus etc. plus the general terms combination of k and a to the n minus k b to the k plus etc. plus the last terms combination of n and b to the n. So I'm going to use this binomial theorem to expand this one. So I have the integral of combination of 0, 5, 3 to the fifth plus combination of 1, 5, 3 to the 4 cosine s plus the combination of 2, 5, 3 to the third cosine square of s plus the combination of 3, 5, 3 square cosine cube of s plus the combination of 4, 5, 3 times cosine to the 4 of s and plus combination of 5, 5 cosine to the fifth of s ds. Let's revisit the combination formula. So if I have combination of k and it's going to be n factorial over k factorial n minus k factorial like this. Alright, so let's take a look at this one right here, 0, 5. It's going to be 5 factorial over 0 factorial and 5 factorial. It's going to be 1. Alright, combination of 1, 5. It's going to be 5 factorial over 4 factorial times 1 factorial. So it's going to be 5. Combination of 2, 5. It's going to be 5 factorial over 2 factorial times 3 factorial. It's going to be 3 factorial times 4 times 5 over 1 times 2 times 3 factorials, right? So 3 factorial and 3 factorial cancel out, right? 4 and 2 cancel out, so we have 2 left right here. So the answer is 10. Now combination of 3, 5. It's going to be 5 factorial over 3 factorials, 2 factorial, right? And we do the same thing right here. So we have 3, factorial times 4 times 5 over 3 factorial times 2 times 1, right? Then this guy cancel out. This guy cancel out. We have 2 right here. So the answer is 10. Next one, combination of 4, 5. It's gonna be 5 factorial over 4 factorials, 1 factorials, right? So it's gonna be 5. And the last one, combination of 5, 5. It's gonna be 5 factorials over 5 factorial, 0 factorial. So it's gonna be equal to 1. Alright. Now keep in mind, in the future, you don't need to calculate this guy and this guy, right? We know that the combination of 0 and is the same thing as combination of n and the answer always equals to 1, right? And you know that this guy and this guy right here, they have the same values. This guy, they have the same values, right? We have the integral of this guy equal to 1, right? 1 times 3 to the 5th. 3 to the 5th is going to be 243. Plus, this guy right here equals 5, right? 3 to the 4 is going to be 81, right? 81 times 5 is going to be 405 cosine s, right? This guy equals 10, right? 3 cubed equals 27. 27 times 10 is going to be 270, right? Cosine square of s plus this guy right here is going to be 10. 10 times 9 is going to be 90 cosine cube of s plus this guy right here equals to 5. 5 times 3 equals 15 cosine to the 4 of s plus the last one, this one equal to 1, so it's going to be cosine to the 5th s altogether ds. Now we look at this one, this guy and this guy right here. We see that the power greater than 1, so we need to print the power down by using the formula cosine square of s equals 1 plus cosine 2s over 2, and cosine cube of s is 3 cosine s plus cosine 3s over 4. Now this guy right here, cosine to the 4 of s, I can write this one as cosine square of s altogether square, right? So this guy turns out to be the integral of 243 plus 405 cosine s plus 270 times 1 plus cosine 2s over 2. 270 divided by 2 is going to be 135. So right here I just write 135 times 1 plus cosine 2s, right? Alright, this guy same thing. I have cosine cube s equals 3 cosine of s plus cosine 3s over 4, right? So I take 90, I divide by 4. It's gonna be 45 over 2 times 3 cosine of s plus cosine 3s, right? Now, this guy right here, it turns out to be plus 15 times this guy right here, 1 plus cosine 2s over 2, right? So if I square this guy both sides, so this guy turns out to be square, right? So it's going to be 1 plus 2 cosine 2s plus cosine square 2s, right? And then over 4, right? So right here I have 15 over 4 times 1 plus 2 cosine 2s, right? Plus, now cosine square of 2s, I'm going to apply the formula one more times. So because I have cosine square of s equal 1 plus cosine 2s over 2, and you see that this angle right here is half of this one. Now if I have cosine square of 2s, it's going to be 1 plus cosine 4s over 2. Alright, so right here, instead of cosine square of 2s, I just write 1 plus cosine 4s over 2. The integral of 243 plus 405 cosine of s plus 135 plus 135 cosine 2s plus 135 over 2 cosine of s plus 45 over 2 cosine 3s plus 15 over 4 plus 15 over 2 cosine 2s plus 15 over 8 plus 15 over 8 cosine 4s plus cosine to the fifth of s altogether ds, right? So 243 plus 135 plus 15 over 4 plus 15 over 8. This guy turns out to be 383.625. Now next one, 405 cosine of s combined with this guy, it turns out to be 472.5 cosine of s. Now next one, 135 cosine 2s, 15 over 2 cosine 2s. Right, so it turns out to be 142.5 cosine 2s. This one right here, we just rewrite it. 45 divided by 2 is going to be 22.5 cosine 3s. This one we need to rewrite plus 15 over 8 cosine 4s ds plus the integral of cosine to the fifth of s ds, right? Alright, now we take antiderivative of this one, so it's going to be 383.625 s plus 472.5 sine s plus this guy is going to be 1 half, right? So we have 142.5 over 2 sine 2s plus 22.5 over 3 sine 3s plus 15 over 32 sine 4s plus c1, right? So this guy is the answer for the first one right here. Now we need to calculate the antiderivative of cosine to the fifth of s ds, right? So this one can be written as cosine to the 4 of s times cosine s ds, right? So this guy is cosine square of s all together square times cosine of s ds, right? Now cosine square of s can be written as 1 minus sine square of s, right? All together square times cosine s ds. Now we need to expand this one, so it turns out to be 1 minus 2 sine square of s plus sine to the 4 of s, right? Times cosine s ds, I can write this one as d sine s, right? So this guy turns out to be sine s minus 2/3 sine cube of s plus 1/5 sine to the 5th of s plus c2, right? Now what we need to do is to combine this guy and then this guy right here, right? So the answer is 383.625 s. Now 472.5 plus 1 is gonna be plus 473.5 sine s plus 142.5 over 2 sine 2s plus 22.5 over 3 sine 3s plus 15 over 32 sine 4s minus 2/3 sine qs plus 1/5 sine to the 5th of s. Alright, C1, C2, I just combine them as a C. And this is the final answer. We're going to learn how to integrate 1 over s to the 6th minus 1 ds. Alright, so we see that this is the power 6. We need to bring this power down by using the difference of 2 square. So it's going to be integral of 1 over s to the 3rd square minus 1 ds. Alright, so I'm going to use the difference of 2 squares. It turns out to be ds over s cubed minus 1 times s cubed plus 1. Now next one, we need to use fraction decomposition to split this guy up. Alright, so it turns out to be the integral of, now this one we just write as power of 3 plus 1 minus s power of 3 plus 1 over s power of 3 minus 1 times s power of 3 plus 1. Put ds right here. So you look at the top, you just literally multiply the top by 2, so you need to divide this guy by 2, so things doesn't change, right? Now this one right here, I just group this guy and this guy, and then this guy I group this guy and this guy. I need to change this side into subtraction side, so this guy turns out to be 1/2 the integral of ds over s cubed minus 1 minus the integral of ds over s cubed plus 1. Alright. Now, I call this one is D1. I call this is D2. Now, I need to calculate D1 first. So, I have D1 equals the integral of ds over s cubed minus 1. Alright. So, in order to do this one, I need to expand the bottom. So it turns out to be the integral of ds over s minus 1 times s squared plus s plus 1. Alright, I just use the formula difference of 2 cube. A cube minus b cube is going to be a minus b times a squared plus ab plus bq. Alright, so if you have the addition side right here, and then this guy turns out to be addition side, and this guy turns out to be subtraction. So keep that in mind. So in order to calculate the integral of this one, I look at the bottom right here. I see this one as minus 1, right? So I just rewrite this one as minus 1 right here. Now ds is the same thing as d of s minus 1, right? Now the bottom right here, s squared, I rewrite s squared. Now s right here, I just split this one into negative 2s plus 3s, right? Now 1 right here, I just put 1 right here. Alright, so I have 3s left right here. Now you know that the first three terms right here is going to be complete square, s minus 1 altogether square. So I have 3s right here. I need to subtract 3 so that when I factor 3 out, it's going to be s minus 1, right? So I just subtract 3, I need to add 3, right? And you see that everything in the bottom right here doesn't change, right? Now this guy turns out to be the integral of ds minus 1 over s minus 1 times the first three terms right here turns out to be s minus 1 altogether square. The next two terms right here, I just factor 3 out, so it could be plus 3 times s minus 1. And then you're going to add 3 right here. Alright, so now I'm going to use substitution, right? So I just let t equal s minus 1. So this guy turns out to be dt over t times t squared plus 3t plus 3, right? Now next one, I need to use fraction decomposition to split this guy up. So this guy turns out to be t squared plus 3t plus 3. I just rewrite t squared plus 3t plus 3 on the top. Okay. Then I'm going to subtract t squared plus 3t. Right? So if I do like this, I have 3 on the top, which means I need to multiply by 1/3 right here. Over t times t squared plus 3t plus 3 dt, right? Now I'm going to split this guy up. So this guy turns out to be 1/3. Now this guy divided by this guy, it turns out to be the integral of dt over t minus. Now the second one, I have the integral of t squared plus 3t over t times t squared plus 3t plus 3. Now Now look at this one right here. I can divide the top and bottom by t. So this guy gone. The top right here, I only have t plus 3, right? Now, observe that if you take the derivative of the bottom, it's going to be 2t plus 3, right? I only have 2, but I only have t's right here, so I need to multiply the tops by 2 so that I have 2t's, right? So because I just multiply by 2, I need to divide by 2 so that things doesn't change. Now this guy turns out to be 1/3 of the integral dt over t minus 1/2 right here. Now this one right here, I just split this one. Now if I take the derivative of this one, it turns out to be 2t plus 3. Now if I multiply this one, it turns out to be 2t plus 6. So 6 right here, I can split this one into 3 plus 3, right? So I just rewrite this one as the integral of 2t plus 3 over t squared plus 3t plus 3 dt, right? And I'm gonna add 3 over t squared plus 3t plus 3 dt, right? Don't forget the integral, and don't forget parentheses right here, and the whole parentheses right here. Alright, so this guy turns out to be 1/3 of the integral of dt over t minus 1/2 the integral of 2t plus 3 over t squared plus 3t plus 3 dt. Now this one right here, I can make the bottom as complete square. So I just divide 3 by 2 and then square, right? So this guy turns out to be t squared plus 3t plus 3 over 2 all together square, right? And then I just add 3 over 2, which means I add 9 over 4, right? So this one I just rewrite plus 3, and then I need to minus 9 over 4, right? So this guy turns out to be t plus 3 over 2 all together square plus now this one right here, you just simplify, so it turns out to be 3 over 4, right? So you have the formula. If you need to take antiderivative of du over u squared plus a squared, it's going to be 1 over a tangent inverse of u over a plus c. Alright, u in this situation is going to be t plus 3.5, right? So this guy turns out to be plus the integral of 3 dt over t plus 3.5 altogether square plus 3 over 4. I can write root 3 over 2 altogether square, so that I can apply the formula right here. Alright, so this guy turns out to be 1/3 of natural log of absolute value of t, right? Minus 1/2 of natural log of absolute value of t squared plus 3t plus 3, right? Plus 3, use this formula 1 over a, which means 1 over root 3 over 2, which means 2 over root 3. So this guy turns out to be 3 times 2 over root 3. tangent inverse of t plus 3½ is going to be 2t plus 3, right? Over a which means root 3 over 2. And you have 2 right here, right? So now we need to simplify this one right here. So this guy's right here turns out to be 2 root 3 tangent inverse of 2t plus 3 over root 3, right? Now remember that we just use substitution by using t as s minus 1, right? So we just substitute s minus 1 back over here. So it turns out to be 1/3 parenthesis natural log of s minus 1, right? Minus 1½ natural log of absolute value of s minus 1 altogether square plus 3 times s minus 1 plus 3, right? And then plus 2 root 3 tangent inverse of 2 times s minus 1 plus 3 over root 3 plus c, right? Now add this to be 1/2, so this guy turns out to be 1/2 multiplied by this, and then this guy turns out to be root 3 only, right? Now I need to combine this guy and this guy using the formula log base a of b minus log base a of c. It's going to be log base a of b over c. So before I'm going to condense this one and make sure the coefficient in front of natural log should be 1. So I have 1/2 right here. I cannot do it. So I need to multiply by 1½ and 2, right? With 1/2 multiplied by 2 is still 1, right? Now 2 right here, I just print back over here. I have log base a of b power of k. It's going to be k log base a of b. Alright, so if you print k back over here, it turns out to be this one right here. Alright, so I can print 2 over here. So this guy turns out to be 1/3 times 1/2 natural log of absolute value of s minus 1 squared. This could be s squared minus 2s plus 1, right? Minus 1½ natural log of, alright, we're going to simplify this one. So if we simplify this one, it turns out to be s squared plus s plus 1 absolute value, right? Plus root 3 tangent inverse of, simplify this one, so this guy turns out to be 2s plus 1 over root 3, alright, altogether plus c, right? Now I factor 1/2 out, right, and I multiply by 1/3, so it's going to be 1 over 6. And then this one right here, I use the formula right here. So it turns out to be natural log of absolute value of s squared minus 2s plus 1 over s squared plus s plus 1. Alright. Plus 1/3 multiplied by this one is going to be root 3 over 3 tangent inverse of 2s plus 1 over root 3 plus c. Sorry, there is a typo right here. When we distribute negative 1/2, so this guy must be negative, this guy must be negative. So we have this guy right here must be negative. Alright, so we just calculated the integral of ds over s cubed minus 1 equals 1 over 6 natural log of absolute value of s squared minus 2s plus 1 over s squared plus s plus 1 minus root 3 over 3 tangent inverse of 2s plus 1 over root 3 plus c, right? So if we do the exactly same thing, right, we will have d2 is going to be the integral of ds over s cubed plus 1. It's going to be 1 over 6 natural log of absolute value of s squared plus 2s plus 1 over s squared minus s plus 1 plus root 3 over 3 tangent inverse of 2s minus 1 over root 3 plus c. Alright, so I'm gonna leave this for you to calculate. So just give you a choice. You do exactly the same thing, the same process, you get the same answer right here. Okay, so now I need to combine this one. So finally I need to calculate 1/2 of d1 minus d2 right here. Have the integral of 1 over s to the 6 minus 1 ds equals 1/2 d1 minus d2, right? So I multiply 1/2 right here. It turns out to be 1/12, right? So I have 1/12 parentheses. Alright, I'm gonna group this guy. Natural log of absolute value of s squared minus 2s plus 1 over s squared plus s plus 1. Alright, minus natural log of the bottom one right here, absolute value of s squared plus 2s plus 1 over s squared minus s plus 1. Close parenthesis. Alright. Now next one, we have 1/2 multiplied by this one. It turns out to be root 3 over 6, right? So I'm going to factor root 3 over 6 out. Minus root 3 over 6. Alright. Parenthesis. This guy turns out to be tangent inverse of 2s plus 1 over root 3 plus tangent inverse of 2s minus 1 over root 3 plus c, right? So this one right here, I can apply the formula log base a of b minus log base a of c equals log base a of b over c. So this turns out to be 1 over 12 natural log of absolute value of s squared minus 2s plus 1, right? Divide by this one, which means you multiply by its reciprocal, which means s squared minus s plus 1 over s squared plus s plus 1 right here. Multiply by this guy right here, s squared plus 2s plus 1, right? Absolute values, subtract root 3 over 6 multiply by tangent inverse of 2s plus 1 over root 3 plus tangent inverse of 2s minus 1 over root 3 plus c. And this is the final answer. We're going to learn how to find the antiderivative of the following. Integral of cosine to the 6s ds. Alright, so before we're gonna jump into this problem, we need to understand the half angle formulas. Alright, so we have sine square of s is going to be 1 minus cosine 2s over 2. Cosine square of s is going to be 1 plus cosine 2s over 2. Sine qs is going to be negative sine 3s plus 3 sine s over 4. And cosine qs is going to be cosine 3s plus 3 cosine s over 4. Alright. This guy actually sine 3s equals 3 sine s minus 4 sine qs, right? This guy right here actually cosine 3s is 4 cosine qs minus 3 cosine s. Alright, so this one I can rewrite as cosine square of s all together q ds, right? The reason why I'm going to write like this because I want to apply the half angle formula right here. Alright, so this guy turns out to be the integral of 1 plus cosine 2s over 2 all together cube ds, right? Now I can bring 1/2 outside, so it turns out to be 1 over 8. The integral of 1 plus cosine 2s cube ds, right? Now I have the formula a plus b cube. It's going to be a cube plus 3a square b plus 3ab square plus b cube. Alright, so I'm going to apply this formula to explain this one. So it's going to be 1 over 8. The integral of 1 plus 3 cosine 2s plus 3 cosine square of 2s plus cosine cube 2s ds, right? Next one, I just rewrite 1/8. The integral of 1 plus 3 cosine 2s. Alright, now this one right here, I'm going to use the half angle formula against right here. Alright, so you see that the angles right here s, and then this guy's double 2s. Now if the angle is right here 2s, and then it turns out to be 4s, right? So I have plus 3 times 1 plus cosine 4s over 2. Now for this guy right here, I'm going to apply the formula right here. Remember that this is s, this guy is 3s, this guy s. Cosine 6s, right? Because this angle right here triple this angle, right? Plus 3 cosine 2s over 4. Alright, so now I just simplify this one. It's going to be 1/8 times the integral of 1 plus 3 cosine 2x plus 3½ plus 3½ cosine 4x plus 1/4 cosine 6x plus 3/4 cosine 2x dx. Alright, so I'm going to combine 3½ right here and 1 right here. It turns out to be 5½, right? Alright, now in order to take antiderivative of cosine of ax plus b, it's going to be 1 over a sine ax plus b, and then plus the constant c. Alright, so this guy turns out to be 1/8 times 3½ sine 2x plus 5½ x plus 3/8 sine 4x plus 1 over 24 sine 6x plus 3/8 sine 2x plus c. Alright, now I'm going to simplify this guy and this guy right here. 3½ sine 2x and 3/8 sine 2x. So this guy turns out to be 1 over 8 times 15 over 8 sine 2x plus 5½ x plus 3/8 sine 4x plus 1 over 24 sine 6x plus c. We're going to explore the antiderivative of cosine to the n of x ds. We have two different cases. The first case, n is even, or n equals 3. We're going to use the formula right here. Sine square of x equals 1 minus cosine 2x over 2. Cosine square of x equals 1 plus cosine 2x over 2. And sine cube of x equals negative sine 3x plus 3 sine x over 4. And cosine cube of x equals cosine 3x plus 3 cosine x over 4. Alright, so we have two different things we need to do. The first thing is n is even. Alright, so for example, if I have cosine to the 6x dx, right? So this case I resolved in the previous videos, so please look at the description below. You will see the videos about this one. Now I'm going to do the second one right here, n equal to 3. So basically we need to calculate the antiderivative of cosine cube of x ds. Now this one can be written as the integral of cosine square of s times cosine of s ds, right? So cosine square of s, I just break it down into 1 minus sine square of s, right, times cosine s ds, right? So this one can be written as 1 minus sine square of s. Cosine s ds is gonna be d sine s, right? Because the derivative of sine s equals cosine s, right? Alright, so it's gonna be sine s minus 1/3 sine cube of s plus c. Alright, so this is the answer for the integral of cosine cube of s ds. Now, second case, n is odd and n must be greater than 3. Alright, so in this case, we must use the binomial theorem. So recall. Alright, if I have a plus b raised to the n, and then I'm going to use binomial theorem to expand this one. So this turns out to be the combination of 0 and a to the and b to the 0 plus 1 and the combination of 1 and a to the n minus 1 b to the first plus combination of 2 and a to the n minus 2b squared plus etc. plus the general terms is going to be k and a to the n minus k b to the k, and plus the last term is going to be n and a to the 0 b to the n. The second one, if we have a minus b, right, so we have a minus b to the n, it's going to be the combination of 0 and a to the n, and then b to the 0, right? So this one right here, we have the negative side right here, we put negative 1 all together, power of 0 right here, right? Next one, the combination of 1 and a to the n minus 1 b to the first, right? So we put negative 1 right here, right to the power of 1, right? Next one, we have combination of 2 and a to the n minus 2b squared. Alright, so we put negative 1 right here, right to the power of 2 right here, okay? Right, the power of negative 1 right here depends on the power of b right here. So keep that in mind. Okay, so in general, I have the general term plus etc. plus the combination of k and a raised to the n minus k b raised to the power of k. So I have negative 1 right here raised to the power of k. And the last terms, it turns out to be the combination of n and b raised to the power of n, right? So this guy turns out to be times negative 1 power of n, right? Now we have the integral of cosine s to the n ds. Now keep that in mind, n is odd and n greater than 3. So n could be written as 2p plus 1, right? And p must be greater than or equal to 2. Alright, so this one turns out to be the integral of cosine s raised to the 2p plus 1 ds, right? Now this guy right here can be written as cosine square altogether power of p, right? So cosine square can be written as 1 minus sine square, right? So it's going to be the integral of 1 minus sine square of s raised to the p cosine s ds, right? But cosine s ds can be written as d sine s, right? Alright. Now, I use the binomial theorem right here. I need to expand this guy, right? So this guy turns out to be the integral of combination of 0p, right? 1 raised to the power of p sine square of s altogether raised to the power of 0. And don't forget to multiply by -1 raised to the power of 0 right here. Alright, next one, I'm gonna add the combination of 1p, right? 1 raised to the power of p minus 1 sine square of s raised to the power of 1 times -1 raised to the power of 1 right here. Alright, plus combination of 2p 1 raised to the power of p minus 2 sine square of s raised to the power of 2 times -1 raised to the power of 2, right? Alright, plus etc. plus the general terms, combination of k, p, 1 power of p minus k, sine square of s power of k, then -1 right here raised to the power of k, right? Plus etc. until the last two terms. Now the terms from the last one should be combination of p minus 1 p times 1 raised to the power of 1 sine square of s raised to the power of p minus 1 times -1 raised to the power of p minus 1. And the last one is combination of p 1 raised to the power of 0 sine square of s altogether raised to the power of p times -1 raised to the power of p, right? Alright, so we need to simplify this one. So this guy turns out to be combination of 0p. 1 raised to the power of p is going to be 1. Sine square of s raised to the power 0 is going to be 1. Now negative 1 raised to the power 0 is going to be 1, right? So the first one you only have this guy, right? Now the second one right here, because negative 1 raised to the power 1 is going to be negative 1. So I put negative sign right here. Combination of 1p, right? This guy right here equal to 1, right? Sine square of s raised to the power 1 is going to be sine square of s. Plus the next one right here, combination of 2p. This guy equal to 1. This guy equal to 1. This guy equal to sine to the 4 of s, right? Next one, plus etc. plus the general terms. It's going to be right here, combination of k, p. This guy equal to 1. This guy equal to sine raised to the 2k, right? Right? Times negative 1 raised to the k plus etc. plus the last two terms right here. The combination of p minus 1p. This guy equal to 1. This guy equal to sine to the 2 p minus 2 of s, right? Times negative 1 raised to the p minus 1. And the last term, the combination of p. This guy equal to 1. This guy equal to sine raised to the 2p s times negative 1 raised to the p, right? Don't forget d of sine s, right? Alright, the last step is to take antiderivative of this one. So this is a constant, right? So the antiderivative of this one should be the combination of 0p sine s, right? Because we have this sine s right here. Minus 1/3 sine q of s, right? And then the combination of 1p we need to put over here, right? Plus 1/5, right? Sine to the 5th s, and this one the combination of 2p, right? Alright, plus etc. plus the general terms right here. It's gonna be negative 1 to the k, right? The combination of k, p. Then sine of 2k plus 1, right? And then you need to divide by 2k plus 1. So you need to put this right here over 2k plus 1. Negative 1 to the p minus 1, we need to rewrite it right here. Alright, then this one right here we need to rewrite it, combination of p minus 1 p, right? Sine to the 2p minus 2 of s, it turns out to be sine 2p minus 2 plus 1 is going to be 2p minus 1 of s, right? And then you need to divide by 2p minus 1. Alright, and the last terms right here, it turns out to be negative 1 to the p. Alright, over this guy right here, 2p plus 1, right? 2p plus 1 of sine to the 2p plus 1 of s. And then you need to rewrite the combination p of p, right? And then don't forget to add c. And then this is your final answer. We're going to learn how to solve this challenging integral. Alright, so we need to integrate s squared minus 1 over s to the 4th minus 5s cubed minus 4s squared minus 5s plus 1. Alright, so to simplify this one, we need to divide the top and bottom by s squared. So this guy turns out to be 1 minus 1 over s squared over s squared minus 5s minus 4 minus 5 over s plus 1 over s squared ds. Alright, now on the bottom right here, we need to combine like terms. So I just rewrite the top 1 over right here. I just write 1 minus 1 over s squared ds. Now I'm going to combine this guy and this guy. So it could be s squared plus 1 over s squared. Now this guy and this guy, I combine this and the factor negative 5 out, right? So it could be 5 times s plus 1 over s. Alright, negative 4, I just rewrite. Observe that if I let u equals s plus 1 over s, alright, then du should be 1 minus 1 over s squared ds, right? Alright, so the top right here, I just rewrite as d of s plus 1 over s, right? Now the bottom right here, negative 4 right here can be written as 2 minus 6, right? So 2 I just bring over here. So I have s squared plus 2 plus 1 over s squared. This guy is the same thing as s plus 1 over s all together square, and this is complete square, right? So this one can be written as s plus 1 over s all together square minus 5s plus 1 over s, right? Minus 6. Alright, so this one can be written as du over u squared minus 5u minus 6. And then we can do the fraction decomposition, right, to split the bottom, right? So the bottom can be written as the integral of du over u minus 6 times u plus 1, right? And this one can be written as the integral of u plus 1 minus u minus 6 over u plus 1 times u minus 6 du. Now on the top right here, if we simplify this one, right, we distribute negative 1 over here. It turns out to be u plus 1 minus u plus 6, right? So it's going to be 7, right? So basically we just put 7 on the top, right? And then we need to divide by 7, right? So that everything remains unchanged, right? Now we need to split this integral. So it's going to be 1 over 7. The integral of u plus 1 over u plus 1 times u minus 6 is going to be du over u minus 6, right? Now this one, u minus 6 divided by u minus 6, so it could be negative the integral of du over u plus 1. Right, so this one can be written as 1 over 7. Now, the integral of this one is actually natural log of absolute value of u minus 6, right? Minus natural log of absolute value of u plus 1 plus c. Alright, so this one can be written as 1 over 7 natural log of absolute value of u minus 6 over u plus 1, right? Plus c. Now, we know that u equals s plus 1 over s, right? So we just substitute s plus 1 over s for u. So it's going to be 1 over 7 natural log of absolute value of s plus 1 over s minus 6 over s plus 1 over s plus 1 plus c. And this is the final answer. We're going to learn how to solve the 2025 MIT integration B. Alright, before we're going to start, go ahead, pause the video and give you a try. Alright, let's get started. Alright, so basically on the top, I just rewrite e to the s and I need to subtract 1. So that is going to be the same thing as the denominator, right? So I just subtract 1, I need to add 1, right? Then I'm going to add 1 right here, which means this guy right here, right? Over e to the s minus 1 ds, right? Now, this guy and this guy right here, I combine this guy, it's going to be 2, right? Plus 2. Now, I'm going to separate this fraction by taking this one divided by this guy, right? So it could be the integral of 1 ds, right? Plus the integral of 2 over e to the s minus 1 ds, right? Now, the first one very simple, right? I need to calculate the second one. So I call this is I. So I have I equals 2 over e to the s minus 1 ds, the integral. Now, in order to calculate this one, multiply the top and bottom by e to the negative s. So I have e to the negative s. This one, e to the negative s, right? So this guy turns out to be the integral of 2 e to the negative s over 1 minus e to the negative s ds, right? Now, side note, observe that, look at the bottom right here. If I take the derivative of the bottom 1 minus e to the negative s, does that mean I have e to the negative s ds, right? So basically, I just replace this guy right here with this guy right here, right? So I have I equals, I can bring 2 to the front, the integral of d of 1 minus e to the negative s over 1 minus e to the negative s, right? Now, I know that the integral of ds over s is going to be natural log of absolute value of s plus c, right? So this guy becomes 2 times natural log of absolute value of 1 minus e to the negative s plus c, right? So the final answer is this guy at I, right? But I equal this, right? So I have the integral of e to the s plus 1 over e to the s minus 1 ds. It's going to be s plus 2 natural log of absolute value of 1 minus e to the negative s plus C. Alright, and this one is the final answer. Let's learn how to solve this challenging integral. Alright, the integral from 0 to 1 of square root of 1 plus 2 square root of s minus s squared. Alright, so let's factor square root of s out to see what happens. The integral from 0 to 1, square root of 1 plus 2 times square root of s times 1 minus s, right? Now, I just rewrite this one, the integral from 0 to 1, square root of 1 plus 2 square root of s times 1 minus s. Now, remember, we have the complete square formula, a squared minus 2ab plus b squared equals a minus b all together squared. If this one is plus sign, this one must be plus sign, right? Now, let this one be a, this one be b. So if I square this one, doesn't mean it's going to be s, right? If I square this one, doesn't mean it's going to be 1 minus s, right? So I just rewrite this integral from 0 to 1. Put the square root side, right? Now I have 1 right here. Rewrite 1 right here. So I just subtract s, right? Now I rewrite this guy right here. Plus 2 square root of s times 1 minus s, right? Then I'm gonna add s, right? And I put ds outside, right? So you see that this guy remains unchanged, right? Now, this guy can be written as square root of 1 minus s squared, right? This guy can be written as square root of s squared, right? So now I can apply the complete square formula right here. So this guy turns out to be the integral from 0 to 1 square root of 1 minus s, right? Plus square root of s all together square ds, right? Now, this guy is the same thing as the integral from 0 to 1. Absolute value of square root of 1 minus s plus square root of s ds, right? Now, since s is between 0 and 1, so this one always positive, right? So I can remove the absolute value side without changing anything, right? So it turns out to be the integral from 0 to 1 square root of 1 minus s plus square root of s ds, right? Now I can convert this one into the exponent, so it will be integral from 0 to 1 minus s power of 1 half, right? This one should be plus side, plus s power of 1 half ds, right? Alright, now you have the formula a s plus b all together power of n. If you take antiderivative of this one, it turns out to be 1 over a times a s plus b power of n plus 1 over n plus 1 plus c, right? Now go back over here. I can rewrite this one as integral from 0 to 1 of negative s plus 1 raised to the 1 half plus s power of 1 half ds, right? So I can apply this formula right here. A in this situation is negative 1, right? So it turns out to be negative s plus 1 power of 3 half over 3 half, right? Plus s power of 3 half over 3 half, right? Evaluated from 0 to 1, right? Now I can simplify this one by substituting 1 into this expression. So I have the first one equals 0, right? The second one right here I have 1 over 3.5, which means 2 over 3, right? The second one I substitute 0 into the first one right here. So I have plus 2 third, and 0 substitute over here, it could be 0, right? So the answer is 4 third. Let's learn how to solve this challenging calculus problem. Alright, let f of s be a continuous function on real number system such that the integral from pi over 4 to pi over 2 cotangent s times f of sine square of s ds equals the integral from 1 to 16 f of square root of s over s ds. They all equals 1, right? Now we need to calculate the integral from 1 over 8 to 1 f of 4s over s ds, right? So I'm gonna let this one be I1. I'm gonna let this guy be I2, right? Now I need to calculate I1 first, right? So in order to calculate I1, I need to use substitution. So I need to remove this one by letting t equals sine square of s, right? And then I'm going to take the derivative both sides. So it turns out to be dt equals, this one I'm going to use the formula u to the n. Derivative is going to be n times u to the n minus 1, and then times u prime, right? So this guy turns out to be 2 sine s cosine s ds, right? Now in order to get cotangent s, I need to multiply the top and bottom of this one by sine s. So this guy turns out to be dt equals 2 sine square of s cotangent s ds, right? Now since t equals sine square of s, right? So I just replace sine square of s equals t, right? So this guy turns out to be dt equals 2 t cotangent s ds, right? Now I need to change the lower limit and upper limit, right? So since s equals pi over 2 and s equals pi over 4, I have the new limits, right? The lower limit, s equals pi over 4, I substitute over here. So I have t equals 1/2, right? S equals pi over 2, substitute over here, I have t equals 1, right? Now I have the new integral. I1 becomes the integral from 1/2 to 1, right? Cotangent s ds, right? I replace this guy with dt divided by 2t, right? So it could be 1/2 2t. I put dt right here, right? Now f of sine square of s is going to be f of t, right? Because t equals this guy, right? So it could be f of t. I'm going to bring 1/2 to the front, so it could be 1/2 integral from 1/2 to 1 f of t over t dt, right? Now I'm going to do use substitution one more time. So I'm going to let t equals 4s, right? So I'm going to take the derivative both sides. So it could be dt equals 4 ds, right? Now I need to find the new limit, upper limit and lower limit, right? Now the lower limit, t equals 1/2, and t equals 1 becomes s equals, because t equals 4s, now t equals 1 half. So I need to divide both sides by 4, s to be 1/8, right? And this one right here, divide both sides by 4, s to be 1/4, right? So I have new interval I1 equals 1 half, interval from 1/8 to 1/4, f of 4s over 4s 4ds, right? Now I need to simplify this guy and this guy, right? So then I multiply both sides by 2. I have the integral from 1/8 to 1 for f of 4s over s ds equals 2 I1, right? But I1 equals 1 right here, right? So it will be equal 2, right? So I just finished the first one. Now I'm gonna move on to the second one right here. Right, I call this one I2, right? So I'm gonna let u equals root s, right? Now I need to square both sides, so it could be u squared equals s, right? And then I need to take derivative both sides, so it could be 2u du equals ds, right? Now I need to change the limits, upper limits and lower limits, right? Now I have the new limit, should be u, right? S equals 1, substitute over here, square root of 1 equals 1, so u equals 1. S equals 16, substitute over here, it's going to be 4, right? So I have the new integral, I2 equals the integral from 1 to 4, right? F of u over u squared, right? Now ds is going to be 2u du, right? Now I need to simplify this one, u squared and u right here. So I have u on the bottom, right? And I need to bring 2 to the front, right? So it's gonna be 2 integral from 1 to 4 f of u over u du, right? Again, I need to use u substitution one more time. So I'm gonna let u equals 4s, right? So then I need to take derivative both sides. So I have du equals 4ds, right? And I need to change the limits, upper limits and lower limits. Now, right here I have u equals 1 and u equals 4, right? For this guy right here. Now, I need to find the lower limits. U equals 1, substitute over here. S equals 1/4, right? U is equal 4, substitute over here. S equals 1, right? So then I have I2 can be written as 2, rewrite 2 over here. Integral from 1 to 4 can be written as 1/4 to 1, right? F of u, which means f of 4s, right? Over u, which means 4s. Now, du is going to be 4ds, right? Then this guy and this guy cancel out, right? So you have 2 integral from 1, 4 to 1 f of 4s over s ds, right? Now I need to solve for this one right here. So I need to divide both sides by 2. So I have the integral from 1, 4 to 1 f of 4s over s ds equals I2 divided by 2, right? But I2 equals 1 right here, right? So it could be 1/2, right? Alright, finally, I'm going to start from here. So have the integral form 1, 8 to 1 f of 4s over s ds is going to be integral form 1, 8 to 1 for f of 4s over s ds plus the integral form 1, 4 to 1 f of 4s over s ds, right? Now this guy right here is going to be right here. So it could be 2 plus this guy is going to be right here, 1 half, right? So the answer is 5 and a half, right? We're going to learn how to solve this challenging integral. Alright, so we need to take the antiderivative of sine of 3s altogether raised to the 7 over 5th root of cosine to the 4 of 3s. Alright, so we need to convert this one to rational exponent first, right? So I just rewrite the top. It's going to be sine of 3s altogether to the 7 over this guy turns out to be cosine of 3s altogether raised to the 4 over 5, right? ds. Now I'm going to bring this one to the top, so it turns out to be cosine of 3s altogether raised to the negative 4 over 5, right? Times, now sine of 3s to the 7, I can rewrite this one as sine of 3s to the 6 times sine of 3s ds, right? Now, sine of 3s to the 6, I can expand this one using the formula sine square of 3s plus cosine square of 3s equals 1, right? So this guy turns out to be the integral of cosine of 3s to the negative 4/5 times 1 minus cosine square of 3s altogether raised to the power of 3, right? Because this one right here, I can rewrite this one as sine of 3s square altogether raised to the power of 3, right? So I can apply this formula right here, right? Now I have another formula, a minus b altogether cube. It's going to be a cube minus 3a square b plus 3ab square minus b cube, right? So I will write this one sine of 3s ds, right? So I just expand this one. It's going to be cosine of 3s altogether raised to the 4/5 times 1 minus 3 cosine square of 3s plus 3 cosine to the 4 of 3s, right? Minus cosine to the 6 of 3s. Now, if I want to take the derivative of cosine of 3s, so what happens? It's going to be negative 3 sine of 3s ds, right? So I look at this one right here. I have sine of 3s ds, right? So I need to divide both sides by negative 3, right? So it could be negative 1/3 right here. So then this guy gone, right? So I just replace sine of 3s ds right here with negative 1/3 d of cosine 3s, right? And I write negative 1/3 in the front, right? Now I just distribute this one. Alright, so it turns out to be negative 1/3 cosine of 3s altogether raised to the negative 4/5, right? Minus 3 cosine of negative 4/5 plus 2 is going to be 6 fifths, right? 3s. Now, plus 3, negative 4 fifths plus 4 is going to be cosine to the 16 over 5, 3s, right? And the last one, minus cosine of negative 4 fifths plus 6, right? It's going to be 26 over 5, 3s, right? Altogether, d of cosine 3s, right? Alright, so I just rewrite negative 1/3 right here, right? Now I need to take antiderivative of this one. Now the new variable in this situation is going to be cosine 3s, right? Because this is d cosine 3s, right? So I have cosine 3s to the negative 4 fifths plus 1 over negative 4 fifths plus 1, right? So it turns out to be 5 cosine 3s all together right to the 1/5, right? This one, if I add 1, it's going to be 11 over 5. So when you divide by 11 over 5, it's going to be 5 over 11, right? So 5 times 3 is going to be 15, right? So minus 15 over 11 cosine of 3s right to the 11 over 5, right? Next one, 16 over 5 plus 1 is going to be 21 over 5. And then you multiply by 5 over 21, right? So it's going to be 15 over 21 cosine of 3s all together right to the 21 over 5 and minus cosine of 3s right to the 26 over 5 plus 1 is going to be 31 over 5. And you divide by 31 over 5 is the same thing as multiply by 5 over 31, right? Plus c. We're going to learn how to solve this integration of composite functions. Let f of s and g of s be two continuous functions on the closed interval 1, 3, such that this one, and we need to calculate this one. Alright, so we need to start from what given, right? So given this one, we need to separate this one. So the first one, I call this one is I, right? I call this one is M. Now I have I is the same thing as the integral from 1 to 3 f of s ds plus 3 the integral from 1 to 3 g of s ds, right? And this one equals 10, right? Now I have m is going to be the integral from 1 to 3 of f of s ds, right? And I put 2 in the front, minus the integral from 1 to 3 g of s ds equals 6, right? I'm going to use the chain of variable to solve this one, right? So I'm going to let u be the integral from 1 to 3 f of s ds, right? And v be the integral from 1 to 3 of g of s ds, right? So I have a system of two equations, right? The first one is going to be u plus 3v equals 10. The second one, I have 2u minus v equals 6, right? Now I need to solve the system of two equations right here, right? So I look at this one right here, I have 3v and this is v, right? So I need to multiply the second equation both sides by 3, right? So I have the first equation I just rewrite, so u plus 3v equals 10. The second equation is going to be 6u minus 3v equals 18, right? Now I'm going to use the elimination method to solve a system of two equations right here, right? So I'm going to add them up right? So I have 7u equals 28. So u equals 4, right? Now substitute 4 for u back into this equation right here. So I have 2 times 4 minus v equals 6, right? So v equals 2, right? So I'm going to go back over here. U equal 4, but u equal this one, right? So I put this one equals 4, right? Now v equals 2, so this one equals 2, right? Alright, so I'm going to start from here. I need to use substitution so that I need to write this one in terms of one of this guy right here, right? Now I'm going to call this one I1. I call this one I2, right? Now for I1, I need to let u be 4 minus s, right? So then du equals negative ds, right? So then ds equals negative du, right? Now you need to change the upper limit and the lower limit, right? So I have s equals 1, s equals 3 right here, right? So we have u equals, substitute over here. So u equals 3 and u equals 1, right? So then I1 becomes the integral from 3 to 1, right? F of u du, and don't forget the negative side right here, right? So it turns out to be the integral from 1 to 3. If you flip the upper bound and lower bound, you need to change the side right here, so it becomes positive, right? F of u du, right? But this guy actually, this guy right here, equals 4, right? Now to calculate I2, I'm going to do exactly the same thing. So I let u be 2s minus 1, right? So then I have du equals 2 ds, right? Now I need to change the upper bound and lower bound, right? So I have s equals 1, s equals 2. Then u becomes 1, right? And this one u becomes 3, right? So I2 becomes the integral from 1 to 3. G of u, right? Now 2 ds is going to be du right here, right? So it could be du. Right, this one is the same thing as the integral from 1 to 3 of g s ds, right? And it's going to be right here, equals 2, right? Now finally, I1 plus I2 is going to be 6, right? Let's explore the challenging integral from the MIT Integration B 2022. The integral from 0 to infinity of 1 over s plus 1 over s altogether square ds. I observe that if we let y equals 1 over s, then s equals 1 over y, right? So there is a symmetry right here. So we're going to need to take advantage of the symmetry to solve this problem. So we're going to let y equals 1 over s, right? So then s equals 1 over y, right? So we're going to take the derivative both sides. So it will be ds equals 1 over y squared. Don't forget the negative side right here. dy, right? Now we need to change the limit. The upper limit is going to be infinity, right? Y approaches infinity, and lower limit y equals 0, right? So we substitute over here. We get s equals 0 and s approaches infinity, right? Now I'm going to let this one be I. So I becomes the integral from infinity to 0, right? 1 over s equal 1 over y, right? Plus y all together square times 1 over y square dy. Then I put the negative sign in the front, right? Now if I change this one to positive, I need to flip the bounds right here, right? So it could be the integral from 0 to infinity, right? Now I need to simplify this one. This guy turns out to be 1 over 1 plus y square over y square, right? Times y square, right? So this guy cancel out. So I have this guy left, right? So it could be 1 over 1 plus y square all together square dy, right? Now this guy suggests a trigonometric substitution, right? So I'm gonna let y be tangent theta, right? So then dy equals secant square theta d theta, right? Now I need to change the upper bound and lower bound, right? So the lower bound y equals 0, upper bound y approaches infinity becomes theta equals, when y equals 0, theta equals 0, right? When y approaches infinity, theta equals pi over 2, right? So I have I becomes the integral from 0 to pi over 2, 1 over 1 plus tangent square theta all together square, right? Times secant square theta d theta, right? It's right here. Now, you know that 1 plus tangent square theta becomes secant square, right? Secant square theta all together square right here, right? Now this guy cancel out, right? So I have the integral from 0 to pi over 2 of 1 over secant square theta d theta, right? Now 1 over secant square, which means cosine square theta, right? So it can be integral from 0 to pi over 2 cosine square theta d theta, right? So it's going to be the integral from 0 to pi over 2. Now cosine square theta is going to be 1 plus cosine 2 theta over 2 d theta, right? So it's going to be 1/2 theta plus 1 over 4 sine 2 theta evaluated from 0 to pi over 2, right? Because you have the antiderivative of cosine of as plus b ds equals 1 over a sine as plus b plus c, right? So 1 over 2 times 1 over 2 equals 1 over 4, right? Alright, so I substitute over here, so it will be 1 over 2 times pi over 2, right? Plus 1 over 4 sine of pi, right? Because 2 times pi over 2, it could be pi. Minus the lower limit right here. When you substitute 0 for theta, every single thing equals 0, right? So you don't need to write, right? So this one becomes pi over 4 because this one equals 0, right? And this one is the final answer. Let's explore the challenging integral from the MIT Integration B 2022. Alright. The integral from negative pi over 2 to pi over 2 cosine s times 1 plus inverse tangent of s over 2 minus cosine square of s ds. Alright, so observe that the lower limit and upper limit are opposite. Think about the even or odd function, right? So I need to distribute this one first. So this guy turns out to be, now I call this one I1 and this one I2. Alright, I need to calculate I1 first, right? So I'm gonna let f of s be cosine s over 2 minus cosine square of s, right? Then I need to calculate f of negative s. It's gonna be cosine of negative s over 2 minus cosine square of negative s, right? And it turns out to be cosine s over 2 minus cosine square of s, right? And this guy actually f of s, right? So the function f of s is even, right? If the function f of s is even, then you have the integral I1 equals 2 times integral from 0 to pi over 2 of cosine s over 2 minus cosine square of s ds, right? So this guy turns out to be 2 times the integral from 0 to pi over 2 cosine s over cosine square of s becomes 1 minus sine square of s, right? This guy turns out to be 2, the integral from 0 to pi over 2 cosine s over 1 plus sine square of s ds, right? Now I'm going to use u substitution, right? So I'm going to let u be sine s, right? Then you have du equals cosine s ds, right? Now I need to change the bound, right? The lower bound s equals 0, the upper bound s equals pi over 2, right? I have new limit. Upper limit u becomes s for pi over 2 substitute over here, so u equals 1. And then s for 0 substitute over here, u equals 0, right? So I1 becomes 2, the integral from 0 to 1, right? Cosine s ds becomes du, right? Over 1 plus u squared, right? So 1 plus u squared, which means inverse tangent of u, right? So it can be 2 times inverse tangent of u, evaluated from 0 to 1, right? So it can be 2 times inverse tangent of 1 minus inverse tangent of 0, right? So inverse tangent of 1 is going to be pi over 4. Inverse tangent of 0 is going to be 0, right? So this guy becomes pi over 2, right? Now for I2, I'm going to let f of s be cosine s inverse tangent of s over 2 minus cosine square of s. Then I need to calculate f of negative s. Turns out to be cosine of negative s times inverse tangent of negative s, right? Over 2 minus cosine square of negative s, right? Now, since cosine is an even function, right? So it's going to be cosine s times the inverse tangent is an odd function, right? So this guy becomes negative inverse tangent of s, right? So I put negative sign in the front right here, right? So this guy turns out to be inverse tangent of s over 2 minus cosine square of s, right? Because the cosine is an even function, right? So this guy turns out to be negative f of s, right? So f of s is an odd function, right? If f of s is an odd function, you have the integral from negative pi over 2 to pi over 2 of f of s ds equals 0, right? So then you have I equals I1 plus I2 equals pi over 2 plus 0 is equal to pi over 2. This is the final answer. We will learn how to solve this challenging integral from the MIT integration B. Alright, we need to calculate the antiderivative of 1 over 1 minus sine s squared ds. Alright, in order to do this one, we need to multiply the top and bottom by this one conjugate. So it's going to be the integral of 1 plus sine s altogether square over 1 minus sine s times 1 plus sine s altogether square, right? Now side note, 1 minus sine s times 1 plus sine s equal to 1 minus sine square of s, right? But 1 minus sine square of s is equal to cosine square of s, right? So the bottom can be written as cosine to the 4 of s, right? The top, you need to expand the top, it's going to be 1 plus 2 sine s plus sine square of s, right? ds. Now, I'm going to split this one into 3 intervals, right? So the first one is going to be 1 over cosine to the 4 of s ds. The second one should be 2 sine s over cosine to the 4 of s ds. And the third one should be the integral of sine square of s over cosine to the 4 of s ds, right? Now I'm going to call this one is I1, this one is I2, and this one is I3, right? Now I need to calculate each of this one, right? So the first one, I1 equals 1 over cosine to the 4 of s. You know that 1 over cosine s equals secant s, right? So this guy is the same thing as secant to the 4 of s ds, right? Now you can split secant to the 4 into secant square of s times secant square of s ds, right? Now you know that secant square of s is going to be 1 plus tangent square of s, right? So I have 1 plus tangent square of s, right? And I need to rewrite secant square of s ds, right? Now I'm going to use substitution, right? So I let u be tangent s, right? So then du equals secant square of s ds, right? Alright, so I1 equals antiderivative of 1 plus u square times du, right? Now we will take antiderivative of this one is going to be u plus u q over 3, right? Plus c. Now I'm going to substitute tangent s for u, so it's going to be tangent s plus tangent q of s over 3 plus c, right? Alright, let's move on to I2. I2 equals 2 integral of sine s over cosine to the 4 of s ds, right? Now we know that sine s over cosine s can be tangent s, right? So I just split cosine to the 4 of s into cosine s times cosine qs, right? So the integral of sine s over cosine s can be tangent s, right? Now 1 over cosine cube of s, it could be secant cube s ds, right? Now this guy is the same thing as 2 the integral of tangent s times secant s times secant square of s ds, right? Now we're gonna use u substitution to solve this one. Let's use b secant s. Then du equals secant s tangent s ds, right? So you have I2 is the same thing as the integral of u square du, right? So it's going to be 2 over 3u cubed plus c. And then you substitute secant s for u, right? So it could be 2 over 3 secant cubed s plus c. This is the answer for the second one, right? Now the last one, I3. Now cosine to the 4 of s can be written as cosine square of s times cosine square of s, right? So you have sine square of s divided by cosine square of s. It could be tangent square of s, right? And then you have 1 over cosine square of s. It could be secant square of s and then ds, right? Now you're going to use u substitution again. You're going to let u be tangent s, then du equals secant square of s ds, right? So then I3 becomes the integral of u square du, right? So it could be u cubed over 3 plus c. And then you substitute tangent s for u, right? So it could be tangent cube of s over 3 plus c, right? So this one is the answer for the I3, right? Now you're gonna add I1, I2, I3, right? So this one I less, this one be I, right? So I becomes I1, which means tangent s plus tangent cube of s over 3, right? Plus I2, it could be 2 third secant cube of s, and then plus I3, which means tangent cube of s over 3, right? And then I'm gonna add a constant c, which means I let this one is c1, this is c2, and this one is c3. c1 plus c2 plus c3 equals a new c, right? So I'm gonna combine these two guys right here, tangent cube of s over 3 and tangent cube of s over 3. So this guy becomes, and then this one is the final answer. Let's learn how to solve this integral from the MIT Integration B 2006 final round. Alright, observe that we have the square root of the rational function right here. We need to eliminate the radical sign. So in order to do that, I'm going to multiply the top and bottom by square root of 1 minus s. So it turns out to be the integral of 1 minus s over square root of 1 minus s squared, right? Now I'm going to split this integral into two integrals. So it could be integral of 1 over square root of 1 minus s squared ds minus the integral of s over square root of 1 minus s squared ds. Now I'm going to call this one I1. I call this one I2, right? So I1 is very easy, right? That is the formula. It's going to be sine inverse of s plus C1, right? Now, to calculate I2, I need to use substitution. So I'm gonna let U be square root of 1 minus S square. Then I'm gonna square both sides. So it turns out to be 1 minus S squared, right? Now I'm gonna take the derivative both sides. So it could be 2U du equals negative 2S ds, right? Now divide both sides by 2, so you have U du equals negative S ds, right? So I2 becomes negative S ds. I replace with U du, right? So the entire derivative of U du over square root of 1 minus S squared is going to be U, right? It's from here. So then this could be entire derivative of du, right? Now it turns out to be U plus C2. But U equals this guy right here, right? So I just replace U with this guy, right? So it could be square root of 1 minus S squared plus C2, right? Now finally, I becomes I1 plus I2. I1 is this guy, right? So it could be sine inverse of S plus I2, which means this guy, right? Square root of 1 minus S square, right? Now C1 and C2, I'm going to combine this guy as C. And this one is the final answer. Let's learn how to solve this tricky intro from the 2025 semi-final MIT Integration B. Alright, the integral from 0 to infinity of q root of s over 1 plus s squared times ds. Now, look at the denominator. The denominator 1 plus s squared suggests a trig substitution, but the numerator q root of s is a bit tricky. So let's try a substitution that balances the power. Alright, so I'm gonna let u equals s power 1 half. Alright, so if I square both sides, it's gonna be u squared equals s, right? So then I have 2u du equals ds, right? Now I need to change the lower limit and upper limit, right? So I have s equals 0, s approaches infinity. Then u must be 0 and u approaches infinity, right? We have the new integral. It's going to be integral from 0 to infinity of s power 1 third over 1 plus s squared ds is the same thing as the integral from 0 to infinity. In order to get s power 1 third, I'm gonna raise power up 2 thirds whole side, right? So then I have u power up 2 thirds equals s to the 1 third, right? So I have u to the 2 thirds over 1 plus u power 4, right? This one turns out to be 2u du, right? Now I need to simplify this one, so it turns out to be the integral from 0 to infinity. U power up 2 thirds times u is going to be u power up 5 thirds over 1 plus u power 4 du. And I'm going to put 2 in the front, right? Now I'm going to use the u substitution one more time. So I'm going to let t be u to the 4. So then u must be t to the 1/4, right? And then I'm going to take the derivative both sides. So I have du equals 1 over 4 t. 1 over 4 minus 1 is going to be negative 3/4, right? Now I need to calculate u to the 5 thirds. So I need to raise this one to the 5 thirds both sides. right? So I have u to the 5 third equals t raised to the 5 12, right? Now I need to change the lower limit and upper limit, so it's gonna be the same thing right here, right? So I have the integral from 0 to infinity of 2 times u to the 5 third. It's gonna be t to the 5 12, right? Over this one turns out to be 1 plus t times du becomes this one, right? So 1 for t to the negative 3 4, right? dt, right? I forgot dt right here. Alright, so to simplify this one, it's gonna be 1 half. The integral from 0 to infinity, right? 2 and 4 is gonna be 1 half, right? Now I need to combine these guys, so it turns out to be t to the negative 1 third over 1 plus t dt. The reason why I did this way, because I'm trying to convert this one into the beta function, right? So this guy actually related to beta function, right? Now recall, the beta function has the form over the interval 0 to infinity. It's going to be b of s y equals the integral from 0 to infinity t to the s minus 1 over 1 plus t, altogether raised to the s plus y dt. It's gonna be gamma of s gamma of y over gamma of s plus y, right? Now our integral is gonna be right here, right? So I need to match them up, right? I have a system of equation. Negative 1 third right here equals s minus 1, right? So I have s minus 1 equals negative 1 third. And this guy right here can be written as 1 plus t power of 1, right? So I have 1 equals s plus y, right? So s plus y equals 1. So I need to solve a system of equation right here. Alright, so very easy, right? S equals 2 third and y equals 1 third, right? Now this guy becomes gamma of 1 third, right? Gamma of 2 third over gamma of 1, right? Because s plus y equals 1, right? Now you have the formula, the beta function of a comma 1 minus a is going to be gamma of a gamma of 1 minus a over gamma of a plus 1 minus a. It's going to be gamma of a gamma of 1 minus a. It's going to be pi over psi of pi times a. Alright, so this one is the formula of the gamma function, right? So from this one I have 1 half of, now remember that a in this situation is going to be 2 thirds, right? A, which means the s value right here. 1 minus a, which means 1 third. So you have 1 half times pi over psi of 2 over 3 times pi, right? Now to simplify this one, it's going to be 1 half times pi. Psi 2 pi over 3 is going to be root 3 over 2, right? Now to simplify this one, I just multiply the top and bottom by 2. So this guy turns out to be 1 half times 2 pi over root 3 Then I just simplify this guy and this guy, so the final answer must be pi over root 3. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand